All right, white light containing wavelengths from 410 to 750 nanometers falls on a grating with 8,600 lines per centimeter. What distance separates the first order of the red end of the spectrum from the blue end of the spectrum on a screen that is 2.5 meters away? Ooh, there we go. So basically, we're going to find the angle for 410, the angle for 750, and then we're going to project that on a screen and figure out how far apart they are. First thing is find D. So D is, this is per centimeter, so 0.01, that's a centimeter, right? Divided by 8,600. So 0.01 divided by, I'm sure I have to do that. That's my first step. I'll do that first. Okay, so D is 1.16279 times 10 to the minus 6th meters, right? And then let's figure out the theta, right? Theta is going to be sine minus 1 of n lambda over d, right? Okay, so theta for the 410, okay, is going to be inverse sine of, let's see, the first order, right? We're talking about the first order, yep. Okay, so 1 times the wavelength, which is 410 e minus 9, that's a 4, right, divided by 1.163 times 10 to the minus 6th. I'm using this as our D here, right? Okay, so let's figure out that. Second sine 1 times 410 e minus 9 divided by that value there. That's 20.646 degrees. Right? And then let's figure out how far that is from the center of the screen, right? So it is 2.5 meters away. And we've got this small angle. Oh, it's 20 degrees, right? 20.646. And we're trying to figure out this distance there, right? X is going to be 2.5 sine of 20.646. Oops, not sine, tangent. There we go, tangent, because this is the adjacent side, the opposite side, right? So 2.5 tangent of the number I just got. And that's going to be 0.942 from the center, right? We did that, right? Okay, so for the 410 nanometer light, the angle, the diffraction angle is 20.646, and on a screen 2.5 meters away, it's 0.942 meters. So let's do the same thing for 750. That's going to be sine minus 1 of 1 times 750 e minus 9 divided by 1.163 times 10 to the minus 6. I'm using this value actually in my calculator. And then that is, I'm actually just going to take the entry that I just did and change the wavelength to 750. Whoa. And I get 40.166 degrees roughly, right? So I'm going to do the same thing here. We've got 2.5, and then we got to make that angle. That doesn't even look anywhere near 40.166, but let's pretend it is. Okay, so this side's going to be 2.5 tangent of. Okay, so 2.5 tangent of the value I just got, and that's 2.11 meters. This is 0.942, right? So the final thing is we must subtract, right? 2.11 minus 0.942. That guy minus, I'm just using the values in my calculator. That's 1.17 meters apart on the screen. Yeah? So the one thing will be here, the one thing will be there, and we would have 1.17 meters between this would be the blue where the blue light is. This would be where the red light is. Okay? The red is going to be on the outside of the spectrum.